Oh man, guys, forgot to make this video, but here I am today making it. This will be short. Get my pins ready here. Boop. Today we're talking about volumes of cylinders. As you know, cylinder is a three-dimensional object that consists of two, not one, but two parallel congruent circles called bases connected with a lateral surface. So, what are some things in the real world? Normally I would be waiting for y'all to spit them out in class, but here's some good examples. Boop. We got bearings, I guess, pipe. They look like riflings. Hay bales, tin cans. What were these called? Candles. More bearings and little piston cylinder houses here. There you go. Looks like a V8. Cylinders looks pretty huge. I wonder if that's a. Nah, I don't think that. Boop. So just some fun facts again. If you would like to, pause the video, jot these down. You need to think of a slinky. If this is a right cylinder and this is an oblique cylinder. As you can see, the altitude is always the height of the cylinder. Okay, always the height. So even if you kinked it over like a slinky, let's think slinky here, the height will still be the same, even though it's kinked over. So you want to write that down. Altitude, height. Okay. Boop. Now, axis is what goes from the center of the two congruent circles. See that? Sometimes it's the altitude. The altitude and axis are the same, and sometimes they're not. Okay. Let me scroll this down. Oh, good gooly mooly. Thing bumped over. There we go. Boop. So, axis of a cylinder is a segment joining the centers of the two bases. If the axis is perpendicular to the base, then the cylinder is a right cylinder. If not, then it's an oblique cylinder. I just want to say salamander. So, cylinder. I'm going to bite my tongue by the end of this video. Anyway, the important part is this right here. Volume of a cylinder. The volume V of a cylinder with a radius R, height H, and base B is given by that form. Holy moly. Donut shop. This one is supposed to be a pi symbol. So clearly the font didn't transfer over onto this computer. So we'll ignore this and I'll rewrite it. But this is foreshadowing. The rest of my slides are probably messed up just like that. Now, fun fact, when we do these prisms, these are prisms shapes. B is going to be the base area. That's why we say big B. Okay? Something you probably remember from middle school. Area of a triangle is 1/2 base times h. This is a little b. See this little b right there? Little bitty b. This is totally different than this big B. Okay? Base area. So, with that in mind, as you can see, the B in this formula is going to be the area of a circle. Again, from middle school, this is the formula for the area of a circle. This took the place of the big B, and the H is obviously the same. Now, if you look over here on the right, you got a picture, and it's labeled. You got R for a radius. H is the height. With those two things, boom. Pi, as you know, is probably going to be 3.14 typically, but when I calculate it, I use my calculator. Again, there's going to be exact answers and decimal answers. For example, calculate the volume of the cylinder. So if I was using the Prism formula, we got big B times H. My base is a circle. So I'll replace the big B with pi r squared times h. So 3 is the radius, 5 is the height. Plug it all in. And get your handy dandy calculator. And look, plug it in like I see it. We got pi, we got to hit shift, pi, parentheses, tree, parentheses square, parentheses 5. I don't know if this will work because pi is kind of funny about not having a time symbol, so let's find out. Ah, it did work. Okay. 45 pi. So volume for the cylinder is 45 pi. This is the exact answer. And if I was asking for decimal, let's just say 2 decimal places. Hit the SD button. 2 decimal places. 1, so 37. 141.37. Bam. Okay, pretty stinking easy. Boop. And we did it. Yay. Let's look. Fun fact. Fun fact. If I knocked over the cylinder, the height is still this axis, for example. This is still the radius. Fun fact. It's kind of like saying if someone is 6 feet tall, they're still 6 feet tall even though when they're laying down. Okay, the height doesn't change when you knock the cylinder over. Don't confuse these two things. So for this example, note height is always the distance between the bases, even when the cylinder is turned on the side. Gold star for that. Again, we're using big BH. Big B is turning into pi r squared because we're dealing with circles. So pi, the radius is 5. And 8 is going to be the height. Get your handy dandy calculator. I'll move this over so I can see what I'm typing. And we're going to go shift pi parentheses 5 square. Oops. Parentheses. Oh, yeesh. Parentheses square. Parentheses 8. Parentheses enter. 200 pi. 200 pi. Again, if I was asking for decimals, hit the SD button, boop, and we get 32. 8 rounds that one up, so 32. 628.32. Well, I couldn't make that fit. I'll put it down here. Boom. Obviously, it'd be square units because it didn't tell us what units or whatever. Not square units. We're dealing with volume. It's going to be cubed units. Oh, man. Ah! I clicked off the screen and I changed the slides over here. Ignore that. Boop. Boop. We were going to go into the penny, but I was just promising I was going to make this short. But for the sake of your sanity, if you wish it, pause the video and I'll show you the end. Well, the answer was down there. Well, you can knock it out. Like I said, I'm trying to make this video short. Let me see if there's some other good. There's the answer. There they be. Forgot it was on the next one. Anyway, boom, there's the volume. I magically changed the color of my marker. There we go. And this was talking about density and whatnot. So keep clicking. Then we discuss the density, grams and whatnot. Mass. I guess that's it. Oh, we need to talk about this. It's about Cavalier's principle. Let's just fly through this. So let's say we take a disc. This is a disc. I know my screen's cut off because I'm using a widescreen monitor. Yada, yada, yada. I tilt it. And as you know, this looks like a stack of CDs. Yes, CDs is what we used back in the day to listen to music. I'm that old. It makes me wonder if y'all ever seen a CD. Or even know what a CD is. It's kind of like those Blu-ray discs. If you know what a Blu-ray disc is, only smaller. We stacked them. Again, pretty cool looking. Boop. If we can take the volume of this cylinder, height, radius, etc. Fun part, if I kink it over, kind of like that slinky idea. Okay, that slinky idea. Would the volume change? No, it will not. Cavalier's principle says, you may want to write this down, if the cross-sectional areas of any two 3D figures are equal for any given height, notice the height did not change, we just kinked the discs around, then the volume of 3D figures are equal. Okay? They should be equal. I mean, because each of these are like slices for the same area, has a corresponding slice out of the original figure. See, the color should still be the same, and trust me, this was a nightmare to work up. They have the same volume, and then calculate the volume of this figure. Again, the height didn't change, nor did the radius. The two numbers we need. Here's a little snippet of another example. Ideally, if this area is still the same as this area, and the heights are the same, then these two figures have the same volume. Hint, hint, this is a test question. I think that's it. Yep. Oh, sorry. Maybe I didn't slow down on that last one. There you go. Pause the video, jot that down, have a cool picture, etc., etc. All right. Up. 11 minutes. Close.